Jupiter is the biggest planet in the solar system. It's held the same orbit for billions of years. What if that changed?
Its gravity influences everything. The asteroid belt, the inner planets, even Earth. One shift and everything changes.
Earth's orbit could destabilize. Asteroids could swarm the inner solar system. Life as we know it might not survive. This isn't just a thought experiment. Jupiter has moved before, and the consequences were enormous. We're covering 3 scenarios. Jupiter moves in, Jupiter moves out, and what if Jupiter didn't exist at all? Jupiter holds 2.5 times the mass of every other planet combined. That's not just big, it's gravitationally dominant. Its gravity well is the deepest of any planet. Everything in the solar system feels Jupiter's pull to some degree. Jupiter acts like a cosmic shield. Its gravity deflects comets and asteroids that would otherwise target the inner planets. The asteroid belt exists because of Jupiter. Its gravity prevented all that material from ever forming a planet. Jupiter even has Trojan asteroids, thousands of rocks sharing its orbit at stable gravitational points ahead and behind. Over millions of years, Jupiter's gravity subtly shapes Earth's orbital eccentricity, affecting long-term climate patterns. Jupiter also anchors 95 moons, including Europa, which may harbor life in its subsurface ocean. It's a mini solar system. Bottom line, Jupiter in its current orbit keeps the inner solar system stable. It's the solar system's security guard. Scenario 1. Jupiter moves inward, toward the Sun, toward us. This actually happened before in the solar system's history. First thing that happens, the asteroid belt gets torn apart. Asteroids scatter into the inner solar system immediately. Mars feels it first. Its orbit stretches into an ellipse. Mars swings closer to the Sun, then farther out, over and over. Then Earth's orbit starts to shift. The gravitational balance breaks. Our axis tilts more. Seasons become extreme. Earth starts getting bombarded. With the asteroid belt gone, large impacts become frequent, extinction-level events. Normally, a major impact hits every 100 million years. With Jupiter closer, that frequency could increase dramatically. Venus's orbit shifts too. Orbital resonances form. There's even a small chance of a Venus-Earth close encounter. Here's the thing, this actually happened. 4.5 billion years ago, Jupiter migrated inward to about 1.5 AU. That inward trip cleared most inner solar system material. That's probably why Mars is so much smaller than expected. If Jupiter stays close, no Grand Tack reversal, life on Earth becomes nearly impossible. Too much bombardment. Scenario 2. Jupiter moves outward, away from us. Seems safer? It's actually a very different kind of problem. Jupiter's protective role weakens. Without its gravity nearby, comets from the Kuiper belt fly straight toward Earth. Long-period comets from the Oort cloud get through. Earth's bombardment rate increases, unpredictably. Saturn also gets affected. Without Jupiter close by, Saturn's orbit grows less stable. Gravitational resonances break. One potential upside, with Jupiter farther away, some parts of the asteroid belt actually calm down a bit. Earth's orbit might actually stabilize more if Jupiter moved far enough away. Less gravitational nudging. But the comet problem outweighs the orbital benefit. More impacts is worse than a slightly eccentric orbit. History supports this. Earth's 5 major mass extinctions all correlate with large impact events or cosmic disruptions. Verdict: Jupiter farther out is a different kind of bad. Less chaos locally, but more cosmic bombardment long-term. Different kind of bad. Scenario 3. No Jupiter at all. What does the solar system look like if it never formed? Completely different. Earth's orbit might actually stabilize more if Jupiter moved far enough away. less gravitational nudging. The result would likely be super-Earths, rocky planets 5 to 10 times Earth's mass filling the inner solar system. This actually matches most other star systems. Super-Earths in the inner zone are the norm. We're the outliers.
Without Jupiter, the asteroid belt material might actually form a small planet, a fifth rocky planet between Mars and Saturn.
But comet bombardment becomes catastrophic. Nothing deflects them. Earth gets hit far more often, much more often. This is much worse. Without Jupiter, the impact rate is orders of magnitude higher. Earth's orbit might actually stabilize more if Jupiter moved far enough away. Less gravitational nudging. Life might still exist on a super-Earth, but constant comet impacts would make complex life much harder to develop. No Jupiter means a different solar system entirely. Life is possible, but extremely different from what evolved here. Radically different, maybe life, but not like ours. Here's the real history. Scientists think Jupiter actually did migrate inward early on to about 1.5 AU. Then Saturn formed and caught up. Their gravitational resonance reversed Jupiter's drift, the Grand Tack outward. Earth's orbit might actually stabilize more if Jupiter moved far enough away. Less gravitational nudging. The Grand Tack solves three mysteries: why Mars is so small, the asteroid belt structure, and Earth's water supply. Jupiter's inward migration scattered water-rich asteroids inward. Some hit early Earth. That's where our oceans came from. Related, the NICE model. All four gas giants migrated outward together, causing a massive asteroid bombardment 4 billion years ago. That reshuffling caused the late heavy bombardment. The moon's craters are the scars of that ancient disaster. Earth's orbit might actually stabilize more if Jupiter moved far enough away. Less gravitational nudging. A hot Jupiter in the inner system ejects every rocky planet. No habitable worlds survive. Those systems are barren. Our solar system is unusual. Jupiter reversed. That's why we have small rocky planets in the inner zone with life. Some call it the Jupiter condition. A gas giant in the right outer orbit may be rare and essential for life. But Jupiter also sent asteroids our way early on. It's both protector and threat. The relationship is complicated. Earth's orbit might actually stabilize more if Jupiter moved far enough away. Less gravitational nudging. Jupiter's current orbit is almost perfectly positioned, far enough to not disrupt us, close enough to protect us. The Grand Tack shaped our whole solar system. Jupiter's ancient road trip gave Earth its water and its current stability. The bigger question: how many solar systems got lucky with their own Jupiter? That answer might tell us about life. Next video, is there a hidden planet at the edge of our solar system? The evidence is surprisingly compelling. Look at these strange orbital paths. Could this be Planet X? Earth's orbit might actually stabilize more if Jupiter moved far enough away. Less gravitational nudging. Drop your answer below. Closer Jupiter or farther Jupiter? I'll see you in the next one.